Okay, in this video, we're going to be finding the composition of functions, and here's the definition. Another method to combine functions is called a composition. Given f of x and g of x, the composition, and here's how we write it. And again, that little circle, that is not multiplication, that is of. We read it as f of g. And here's actually the definition of it. F of g of x, and you don't have to put the of x, simply means f of g of x. The same thing when we find f of 3, that means to take and plug in 3. Well, how do you find f of g? You plug in g. We're going to be plugging a function into a function. Now, the domain is a little bit different here. The domain of a composition, like f of g, is the domain of g such that g is the domain of f. And that sounded really confusing, but here's pretty much all we're saying is since we're going to plug g into f, to find f of g, we've just got to make sure that there's no value of g that we're plugging into f that would make it undefined. So g of x can't be anything, it can't equal anything that we would make plug into f to make it maybe divide by 0 or the square root of a negative. So just be cautious when we're doing the domain there. Okay, first off, given f and g, let me zoom in. F of g, and what I like to do is I always like to start out writing f of g means f of g. So this is what I'm going to be plugging in. So I'm going to take my f function, which is x plus 7. In the place of x, I'm going to put this. I'm going to put g, so that'd be x squared minus 4. So again, I'm taking out the x, plugging in my g value. Those parentheses are no longer necessary. That'd be x squared. I could actually erase them. Parentheses not necessary, combine your like terms, and you simply get x squared plus 3. And that would be f of g. And again, you've just got to make sure that there's nothing that g is equal to that you could plug into this that would make it undefined. F of x is fine everywhere, so it does not matter what we're plugging in for x. We're fine everywhere. G of f now, let's do it backwards. Let's take our, let me write this. We're finding g of f, so we're going to take our g function and plug f into it. So our g function was x squared minus 4. So we got x squared minus 4 was g. I'm going to take out the x, and in its place, I'm going to plug in f, which was x plus 7. And again, make sure with our domain that we're not plugging anything in here that would have made our g function undefined. To square that, we're going to FOIL it, x plus 7 times x plus 7, and you would get x squared plus 14x plus 49. Bring down the minus 4, combine like terms, you get x squared plus 14x plus 45. And again, our domain there would be all values from negative to positive infinity. The next one, f of g, and now we're going to have some domain issues here. So we got to be careful with this one. F of g simply means, again, f of g. We're going to plug g into f. So we're going to take our f function, which is 3 minus x. We're going to take out the x. We're going to plug in our g, which is x over x plus 1. Okay, so let's combine some like terms, find some common denominators here. So my first function, I need an x plus 1 on bottom, so I'm going to multiply top and bottom by x plus 1. And I'm going to subtract x over x plus 1. And that gives me 3x plus 3 minus x all over x plus 1. It's going to be my function. It's already obvious what my domain, I can pull my domain from here after I get done now with these problems. 3x minus x gives me 2x plus 3 over x plus 1. And obviously x cannot equal negative 1 will be to my domain. The next one, g of f, we're going to take g and we're going to plug in f. So let's take our g function, which is x over x plus 1, x over x plus 1, so parentheses plus 1. And again, I do that because everywhere I have the x, I'm going to plug in f, so I just leave parentheses in its place. So I'm plugging in 3 minus x everywhere, so 3 minus x there, and 3 minus x there. So the top combines with nothing. The bottom parentheses are no longer necessary. I can combine my 1 and my 3, and that gives me 4 minus x on bottom. And my domain's a little bit different here because what value would force this bottom to equal to 0 and that'd be x cannot equal 4. And you can see now what I was talking about before. Okay, to find g of f, if I were to plug in a 4, if x was equal to 4 here, that would be 3 minus 4, which would give me a y value of -1. Now, what am I about to do after I plug that 4 in? I'm going to take that answer and I would be plugging it into this. And if I plugged in 4, I'd get -1. And that -1 that I just got, when I go to plug it in here, I get -1 plus 1, which would give me a 0 on bottom. So that's the reason plugging in a 4 into my original function would end up making my g of f there, it end up making it undefined. Okay, the next one, find f of g. Again, I like to write down f of g first, so I'm going to take f, which is 9 minus 2x to the third, and in the place of the x, I'm putting 4x plus 1. Now that is a correct answer, and since you can look at both of these over here, there's absolutely nowhere these domains restricted. There's no division by zeros, there's no radicals. So my domain already, I can tell, is going to be all real numbers or negative to positive infinity. Now instead of leaving our answer like this, let's get some extra practice in how would you multiply 4x plus 1 to the third power. And just a reminder, you would do 4x plus 1 times 4x plus 1 times 4x plus 1. You would multiply 2 at a time. And you would have 4x plus 1 times, multiply that out, it gives you 16x squared plus 8x plus 1. If you were to FOIL it, take 4x, multiply it by all three. That'd be 64x to the third plus 32x to the second plus 4x. Take the 1, multiply it by all three. And again, I like to do this. I like to, when I do 1 times 16x squared, sometimes I'll just line it up right here below. And the reason I do that is because then it lines all my like terms up. So that would give me a final answer of 9 minus 2 parentheses. 4x minus plus 1 to the third is 64x to the third plus 48x to the second plus 12x plus 1. Let's distribute our -2. That'd be -128x to the third, a -96x to the second, a -24x, and a -2. And our last step would be to combine these like terms, and instead of rewriting the whole thing, a +9 and a -2 would be a +7. Let me just erase them and put that +7 to save us from having to write it all again. Okay, example 4. Well, or B part, excuse me. G of f. So now I'm going to find g of f, which means I'm going to plug f into g. So let's take g, which is 4x plus 1, 4x plus 1, and plug in its place f, which is 9 minus 2x to the third. And this way is going to be a whole lot easier. And again, my domain here, there are absolutely no restrictions with either function, so I don't have to worry about any domain restrictions. That'd be 36 minus 8x to the third plus 1, which again, we can just erase the 36 and write 37 when we combine the like terms. Example 4, f of g. First off, let's find any domain restrictions. Now with our first one, I can only plug in values from -5 to infinity. And again, the way I found that was you can take the x plus 5, you say the stuff under a radical has to be greater than or equal to 0, move it over, and you get x is greater than or equal to -5. So that's my restrictions there, so let's keep those in mind. Here, you can have an x value of anything. So when we find f of g, that means we're going to take f, plug in g. So f is the square root of x plus 5, where x is x squared. So now as far as our domain restrictions go, even though f had restrictions, f could be things from -5 to infinity, you would think, well, then f of g would have those same restrictions, but it doesn't. Because go back and look at what you now have. When you put stuff in for x here, okay, and you square it, this says that you could place anything that you want to in for that x value. And when you square it, if you put a negative in there, -3, and you square it, all of a sudden it becomes positive. And when you add 5 to it, you still have a positive that you're taking the square root of. The only thing that you cannot take a square root of here is any value from -5 to infinity. So what, here, I guess this would be a good way of looking at it. What would force this right here to be a -5? Could x squared ever equal a -5? Could it ever equal a -6, a -7, a -8? And the answer is no, because when you square something, it's never going to be negative. So my domain here would be anything. I can plug in anything for x that I want to, and it's not going to make that square root the square root of a negative. The next one, to find g of f. G of f, I'm plugging in f, so let's take g, which is x squared, and let's plug in f, which is the square root of x plus 5. And we know that when we square a square root, that it's going to remove those radicals, and it's going to give us just plain x plus 5. Now, you could put those in absolute value bars, because if you think about it, if you square something, it's always going to be positive. So we could put those absolute value bars around it if we wanted to. But now let's talk about domain. What can x be here? Because we've got to be careful not to put anything in here that's going to make this a negative value, because you can't take the square root of a negative value. And then that simply goes back to my other domain. The things that would force this right here to be negative would be those initial domains, the things that I'm plugging in, uh, excuse me, to f. So therefore, I know that I can't plug anything into f that's going to make it negative. So my domain here is going to be from all values from -5 to infinity. Which is, again, I could have put absolute value bars around this, but I don't have to now, because it's always going to be positive anyway, as long as I'm plugging in values from -5 to infinity. Example number 5, f of g. Take your f function, which is x to the third minus 1, plug in the cube root of x plus 4. We really don't have to worry about domains here, because the domain here is negative to positive infinity, the same for this one. You can take the cube root of anything, so you can plug in anything. A cube root and a cube undoes each other, so that's x plus 4 minus 1. So this function, this composition, is x plus 3 with the domain of negative to positive infinity. Now g of f, let's try to find it now, g of f. So I'm going to take my g function, which is the cube root of x plus 4, the cube root of x plus 4, and in the place of x, I'm going to plug in my f, which is x to the third minus 1. Ask yourself if the parentheses are necessary. They're not, so you can remove them. So that'd be the cube root of, combine your like terms, that'd be x to the third plus 3. Again, but since both domains were infinite, then the domain of this one would also be an infinite domain, all real numbers. Okay, examples 6 and 7. Now we're finding compositions and we're plugging in points. So f of g of 3, we're going to find f of g of 3. Now let me show you a shortcut for this one. There's two different ways to do it. First way, we'll work it the long way. Let's actually find f of g, which means we're going to take f, which is the absolute value of -2x. And in the place of x, we're going to plug in g. So that would be the absolute value of -2x minus 2. That's f of g. Then we could plug in 3, and that'd be the absolute value of -8, which would give you 8 as a final answer. The other way of working this is to do exactly what I just wrote here. F of g of 3 is the same thing as f of g of 3. So you could actually instead find g of 3. That's going to be 3 plus 1, which is 4. So now, since this is 4, we are finding what is f of 4. And when you find f of 4, you're going to plug in a 4 here. That's the absolute value of -8, which is also the exact same answer. So you can work it either way. So g of f of -5, you could find g of f of -5, which I feel like is probably going to be the easiest method. Or you could find g of f and then plug -5 into that. So let's find g of f of -5. So that's going to be f of -5 first. Always start on the inside. So f of -5, plug in -5 here. and you get 10. The absolute value of 10 is 10. So now since this is 10, we're going to find g of 10. So that'd be 10 plus 1, which gives you 11. So g of f of negative 5 would be 11. Here, f of g of 9, let's find f of g of 9. Let's start with g of 9. G of 9, plug in a 9 here, that's going to be the square root of 9 minus 4 is the square root of 5. Then we're going to take that square root of 5 and we're going to find, right here, square root of 5, so we're going to find f of the square root of 5. So take out these x's and you've got the square root of 5 squared plus 5 times the square root of 5. When you square a square root, it removes it, so that'd be 5 plus 5 root 5, and that would be the exact version. You could plug in the decimal version if you'd like. G of f of 7 would be g of f of 7. Let's start with f of 7. So take out the x's and plug in 7's. That would be 49 plus 35, which is 84. So now let's find g of 84, because again, it's finding g of f of 7. G of 84 would be the square root of 84 minus 4 would be the square root of 80, which you could leave it like, you could write it as a decimal, or you could break it into the square root of 16 times the square root of 5, which is 4 root 5. Okay, now we're working these problems backwards. We're decomposing functions. And we're said, try to find some functions f and g such that f of g, so we're plugging g into f, is equal to this function. So just pretty much look and see what looks like it's been plugged into something else. This stuff inside parentheses, if we let it be our g, which is what got plugged in, well, what did it get plugged in? We'll take that out. And it got plugged into stuff to the third power. So we can let our f be the entire function, which is stuff to the third, and let g be the stuff on the inside that got plugged in, which was 1 minus 2x. And if you were to find f of g, if you were to plug this into this, you would get that function back. Let's try another one. So again, we're looking for what's the g that got plugged in. Now this is the stuff that's on the inside, so we'll let that be our g. So if g of x was equal to x squared plus 1, and we plug that into what function, would it give us this? We'll take that out and replace it with an x, and you get the cube root of x. And again, if you were to plug that in where that x is, you would get this stuff back. Next one. And there's multiple ways to work these. I could let this be my stuff that got plugged in. So we could let our g of x be x plus 7 just to keep it simple. And we could say, well, then what did you plug it into? Well, instead of 4 over x plus 7, if you put 4 over x minus 1, if you put x plus 7 right there, then you would get this stuff. So that would be your f and g that you composed. Your inside stuff here is x plus 5, so we could let our g of x be that. And if we were to plug in x plus 5 into this function, negative 1/2 absolute value of x plus 3, if we were to take that x out and put in the x plus 5, then it would turn it back into that function again.